Hi everyone, Assalamualaikum. We recall back from the previous video, we have discussed how to evaluate limits using direct substitution. Right? It's very easy, very simple. We just plug in the value of x into variable x. Then we get the value of the given limits. Now, we are going to discuss the other techniques to evaluate limits. Okay? Alright, we use this technique to evaluate limit when limit x to a fx over dx give the answer 0 over 0. Right? From the properties of limit, theorem number 5, under division rule, if we have limit x to a fx over dx, we can separate the division. So we can write equals to limit x approaches a fx over limit x approaches a dx. Okay? We use this rule when limit x to a dx not equals to 0. Right? What happens if limit x to a fx equals to 0 and limit x to a gx equals to 0? Means both numerator and denominator equals to 0. Okay? Right now, we look at this. If we have limit x to a fx over dx, okay, using this theorem, okay, so we can write limit x to a fx over limit x to a dx. Okay, we separate the division and let's say both numerator and denominator equals to 0. So we will get 0 over 0. Right? Did you know that 0 over 0 is not equals to 1? Since we have numerator and denominator are the same value, it doesn't mean that 0 over 0 equals to 1. Seriously? 0 over 0 is actually undefined. Okay? Because calculator will give error when you calculate 0 over 0. Right? Using direct substitution, if we get limit x to a fx over dx equals to 0 over 0 after we use direct substitution, in this case, we can't evaluate limits by direct substitution, right? Because 0 over 0 is error, right? The following are some other techniques that can be used. If limit x to a fx over dx equals to 0 over 0, we can evaluate using this technique, right? Method 2, evaluating limits using factoring and cancelling. We use this technique when fx or dx is a quadratic and polynomial, right? Or fractions within fraction. Or there is no terms containing surd. Surd means the symbol of square root. Okay? Or trigonometric function. Right? Let's look at some examples. Now we look at example 1 under evaluating limits using factoring and cancelling. Find limit x to 2 x squared minus 4 over x minus 2. Alright? Using direct substitution, we can solve limit x to 2 x squared minus 4 over x minus 2 by plugging the value of 2 into variable x. So we get this. Okay, and after we simplify, we get 0 over 0. And remember, 0 over 0 is error. Okay, so what should we do is limit x to 2 x squared minus 4 over x minus 2, we can write into the form of limit x to 2 x plus 2 times x minus 2 over x minus 2. Alright? What should we do from here? We need to factoring. Alright? From here. Okay, this is quadratic function. So we factorize the quadratic, right? And after that, we have the same factor, okay, from numerator and denominator. So we can simplify, okay? We cancelling the same factor, alright? Then we can write limit x to 2, x plus 2, okay? From here, we can use direct substitution after factoring and cancelling, okay? So after we use direct substitution, we get this, okay? We substitute the value of 2 into variable x here. And remember, after direct substitution, no more limit expression, right? Then we simplify, so we get the final answer equals to 4, right? So that's the way how we evaluate limits when we use direct substitution. The answer gives 0 over 0. Okay, if the function is given in terms of quadratic or polynomial, we can use factoring and cancelling method, right? Now we look at example 2 under factoring and cancelling method. Find limit x approaches 1, 1 minus x squared over x minus 1. Using direct substitution, limit x to 1, 1 minus x squared over x minus 1 equals to, we write this, okay, we just replace 1 into variable x here. And after we simplify, so we get 0 over 0. And 0 over 0 is error, okay? So what should we do is, we write limit x to 1, 1 minus x squared over x minus 1 equals to limit x to 1, 1 plus x times 1 minus x over x minus 1. Okay, from this quadratic function, we need to factorize. Okay, so we get this. Okay, so from here, we factoring. Okay, we now under factoring and cancelling method. Okay, so after that, we cancelling. Okay, right. But wait, are you sure can cancelling? 1 minus x is not equals to x minus 1. So we can't cancelling. Please be careful. Alright? So how to cancel it? So what should we do is, we need to write 1 minus x equals to, we put minus sign and bracket, and then we just exchange x and 1 here. Okay? Alright. So from here, we can write 1 minus x equals to negative bracket x minus 1. Okay? Let's say we try to expand. Okay? To check whether both sides are equal. Okay? We expand negative 1. We multiply negative 1 and x here. So we get negative x. Negative times negative 1 equals to positive 1. So from here, we get negative x plus 1, which is equivalent to 1 minus x. Alright? So in this case, we need to write factor 1 minus x into this form. Alright? So from here, we can write limit x to 1. Okay? We write 1 minus x equals to negative bracket x minus 1. Okay, from here. Okay, and to avoid error, we better put in front because we have negative sign here. Okay, because if you put negative here, okay, some student tends to make mistake. Okay, maybe they think that is minus. Okay, I mean minus operation. Okay, but actually this is multiplication operation, right? So to avoid error, we better put this factor in front. Okay, so now we write 1 minus x equals to negative bracket x minus 1. Okay, because this is equal, right? And after that, we have same factor from numerator and denominator. So from here, we can cancelling. Okay? Alright. And at the same time, we can move out negative sign from limit expression. Okay? So we get this. Negative and then limit x to a 1 plus x. Okay? After we factoring and cancelling, so from here, we can use direct substitution to evaluate limit. Okay? So from here, we use direct substitution, so we get this. We just replace 1 into whatever x here. Okay? But we still have minus sign in front here. Okay? And remember, after direct substitution, no more limit expression. Right? And after that, we simplify, so we get the final answer equals to negative 2. Alright? So this is the final answer. We factorize the quadratic and then we cancelling. Okay? If when we use direct substitution, the answer give 0 over 0. Right? Got it? Coming up next, evaluating limits using factoring and cancelling continue. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.